Hello, my name is Arvo Tully, and I'd like to show you a new feature in Vision 4D version 3.2. The new feature is the new region growing operator. We can use this in conjunction with Blob Finder to detect cells which might be otherwise impossible to segment. So in this case, we have a very complicated cell structure that we'd like to, series of cells that we'd like to segment. What we're going to do is we're going to use some of the new features in Vision 4D version 3.2 to go ahead. We're going to do some denoising. Then we can normalize the nuclei. Then what we're going to do is we're going to identify the nuclei using the Blob Finder. And then we're going to use the region growing on the red channel to extend the cells out. And then we're going to use region growing on the green channel to find the maximum extent of these cells. And then we're going to go ahead and compartmentalize these, and we're going to put these all together as complete cells so we could get accurate volume and intensity measurements on a per cell basis. So let's watch what happens and how this works. So first we're going to take the entire image set. Then we're going to go ahead and smooth out all the channels and remove a little bit of noise in there. New in Vision 4D version 3.2, all of the denoising operators are now three-dimensional, and this leads to them being faster in most cases. So we're also going to use this new normalization feature. Now normalization helps to even out any variations in intensity in the image, and I'm going to, in this case, use the advanced normalization, and I set it to approximately the size of my nuclei, which in this case are about 8 or 9 microns. Now we're going to go ahead and store those. And now in the Blob Finder, now the Blob Finder interface is slightly different in version 3.2, and we're going to go ahead and select the nuclei channel. We're going to specify the diameter of the nuclei, and then we can take a look at setting the probability threshold, and we can see the new preview here in the probability map to get an idea of how big and how low we need to set this. In this case, the 20% works pretty well, and that's the new probability, which is kind of a pre-processed image. And then we can take a look at the result to get an idea of where we need to set the split sensitivity to split out these cells. So once we're happy with that, I'm going to turn off the preview and then go to the next step and let that calculate. So now this has gone and identified the nuclei. Now what we're going to do is we're going to grow out the nuclei into the red channel. So we're going to use a watershed segmentation on the red channel. We're going to pick an intensity value that identifies these nuclei pretty well, and then we're going to specify a maximum distance to grow these out. So in this case, we only want to grow out about 6 or 7 micrometers. We don't want to grow out too far. So once we're happy with that, we can also use a preview here. We can take a look at the how far it's going to grow out in the foreground, and then we're going to take a look at the result and see a preview of how far those are going to grow out. We're happy with that, so I'm going to go ahead and run that. And again, this does run in 3D. And so now once that's done, we can see that we've grown those out. And we're going to take that, and in our next region growing, we're going to go ahead and make sure we have the correct input. We're going to use the input for the second region growing as the, so we're going to use the first region growing as the input for the second region growing. We're going to grow this out to get a very accurate measurement of the phalloidin of these cells. So we're going to go ahead and do that. So now we're going to run the region growing again, second time. And the reason we're doing this is because the end user wants to find all of these very fine processes. And if you were to do this in one step to going from the nuclei out, this doesn't work too well, because what happens is that there are some cavities and some empty parts at the cells where it doesn't completely connect. Whereas if we do this region growing twice, it fills everything up. So now we're able to use the compartmentalization, the compartments feature, to organize these into complete cells, and then we can go ahead and save them. Now let's go ahead and take a look in 3D and see what these look like. So now you can see that we've got a nice segmentation of these cells, and now we can go in and use the objects table to get good measurements about all these cells. So if we were to look at the compartments, we can go in and see what's going on here and pick up all of these measurements. So anyway, I hope you found that interesting, and thanks for watching.